Okay, today we're switching gears and we're starting some new content, and we're just going to call this a mini unit over exponents. And you should know how to use exponents and the different rules back from Algebra 1 because I know that you spent quite a bit of time on it, at least if you had me in class you did. So this should just be a review of already familiar concepts, and so that's why we're calling it a mini unit. We're not going to spend a lot of time on just the exponent rules. We're just going to spend a few days here, a few lessons, and then we're going to switch gears to rational expressions. But in order to do the rational expressions, you have to understand the exponent rules first. Okay, so that's where we're going to start. Today's lesson 16. I can simplify expressions using exponent rules is your I can statement or learning objective for today. And then as always, remember I'm going faster in the video than I would be in person, so you're welcome to pause and rewind and watch it at your own pace. And if you have questions or need help, please let me know. And please write down these rules and write down the examples for me. That'll help you when you get to your assignment in Math Excel. Okay, so first, before we actually start looking at the rules, we want to talk about just the basics of exponents. So if you have a number, say I have 3 squared, okay, the 3 is called my base, and that 2 is my exponent. Okay, that should be familiar terminology to you. So the base is what's being raised to the exponent. The exponent is the power. Okay, and then when you have variables thrown in, we can have an extra piece. So if I say 4x to the 5th, okay, that 4 is now my coefficient. You guys should know that's the number that comes in front of a variable. That x is my base, and that 5 is my exponent. And as we talk about the rules, you're going to have to know the difference between a coefficient, a base, and an exponent. Okay? And so make sure that you know the difference if you need to. If you don't know, then write these 2 examples down. They'll be very helpful for you moving forward. The first rule we're going to look at is the negative rule. So take just a second and write this down. So if you have the negative rule, it means if you have a to the negative n power, you rewrite it as 1 over a to the nth power. Or if you have 1 over a to the negative n, you change that to a to the n. So what I want you to notice is that the negative exponent means move. It does not mean a negative number. If you have a negative exponent in the numerator, you put it in the denominator. If you have a negative exponent in the denominator, you move it to the numerator. Okay, you also need to make note, you can't leave a negative exponent in an expression, ever. If you still have a negative exponent in your expression, you have to keep going. You have to keep simplifying. You cannot leave it in there, okay? It will not be considered correct. So make sure you take care of all negative exponents. Now, we'll look at a couple examples of how this works. So let's see. So if you were given 4 to the negative 6th power, you would rewrite that as 1 over 4 to the positive 6. So that does not mean a negative number. It means we put this in the denominator. We change the exponent to positive and put a placeholder of 1 on top. Okay. Another example is if I have x to the negative 2nd power, that would be 1 over x squared. Right? Or if I had 1 over x to the negative 3rd, I would rewrite that so that this time the negative's in the denominator, so we bring it up top, that negative exponent, and that's just 1x to the 3rd, or 1x cubed. Okay, if I have 1 over 2 to the negative 3rd, again, we have a negative exponent in the bottom, so we're going to move it to the top. It'll be 2 to the 3rd. All right, if you have negative 3x to the negative 2nd, Okay, that you have to look at it piece by piece. That negative 3 does not have an exponent, so we leave it where it is. But this x has a negative exponent, so we put it on the bottom. So x squared goes down to the bottom. All right, or if I have 4 over x to the negative 4th, okay, I can rewrite that. The 4 stays. It does not have a negative exponent. This x does, so it moves up. So we have 4x to the 4th. Okay, so that's how your negative exponent rule works. That negative exponent means move it. Does not mean a negative number. Okay, our next rule is the 0 rule, and this one is the easiest of them all. Anything raised to the power of 0 is 1. So your example, a to the 0 power equals 1. Okay, and that will always work. So let's look at some examples of that. So if I give you 4 to the 0 power, that equals 1. If you have x to the 0 power, it equals 1. If you have 5,000 to the 0 power, it still equals 1. If you have the quantity x, y, z raised to the 0 power, it equals 1. So anything raised to the power of 0 is 1. And so you never want to leave an exponent of 0 in your expression either, because it always changes to 1. Okay? And so let's look at a couple more. If I give you 4x to the 0 power, okay, x to the 0 changes to 1, so that's like 4 times 1 is just 4. So what I want you to notice is that this x to the 0, it kind of cancels itself out because it changes to 1. And we know if we multiply by 1, nothing changes. So if I have 5x to the 0y, that would change to just 5y. Or if I had 3 over y to the 0, that'll just be 3. Okay? So anytime you have something to the 0 power, essentially you can mark it out. If there's nothing left, you just have a 1. If there is something left, you just bring that over. Okay, the last rule that we're going to look at today is the product rule. And so that rule says that when you're multiplying powers with the same base, you add the exponents. And here's your little example. If you have a to the m times a to the n, your base is a, and then you add those exponents, so m plus n. Okay? Now, I know that can be difficult, and we're talking about multiplying powers, adding exponents. So sometimes this is more helpful just to think of it this way. When you're doing the product rule, you multiply coefficients, keep the base, add the exponents. And so we will practice some of those. And this is the rule where it's really, really important to know the difference between a coefficient and a base and an exponent. Okay? And you have to be able to identify each of those to correctly do the rule. All right, so we'll start out with just some numerical examples. So if you have 4 squared times 4 to the 5th, all right, our rule says add the exponents. So our base is 4, so we keep the base and we add the exponents, and that's 7. Okay, an easy way to see that if you're having trouble is you can list it out. 4 squared means 4 times 4. 4 to the 5th is 4 times 4 times 4 times 4 times 4. And then you can count how many 4s you have, and it is 7. Okay, so that is the same thing that we're doing. We're just skipping the step of expanding it all out. However, you're welcome to do that, and that's really helpful for some students. Okay, here's another example. X to the 3rd times x squared is x to the 5th. Okay, keep the base, add the exponents. All right, here's another one. 3x times 4x squared. This one, we have to know the difference. So the numbers in front are our coefficients. So 3 times 4 is 12. Okay, our base is x, and our exponents are 1 and 2 makes 3. Okay, and so there's something else important to know if you didn't realize it already. If there's not an exponent visible on the variable, then the exponent is 1. Okay, let's do a few more examples. Okay, so on this one, our coefficient, so 5 times 2 is 10. Keep the base, so x and x. So 2 and 1 is 3. And then we have y. 3 and 4 is 7. Okay, that's what we're doing here. Let me do one and let me expand it out and show you how it works. So if I say 2x cubed times 5x cubed. Let's just do it that way. So this is how we would expand it out. We would say 2 times x times x times x times 5 times x times x times x. And so it's all multiplication. And so we know that order doesn't matter in multiplication. So I can reorder this so that the 2 and the 5 are together, and that gives me 10. And then my base is x, and I have 1, 2, 3, 4, 5, 6 of them. Okay, so I get 10x to the 6th. And again, like I said before, you're welcome to expand it out if that's going to help you. It should work out the same every single time. All right, now, real quick before we move on, let me show you a couple problems where you have all of your rules combined. So, say I have 3x to the 0, y to the negative third times 5x to the fourth, y to the negative second. Okay, so I'm going to do, you can do it a couple different ways. I'm going to do the product rule and the 0 rule first. I'm going to leave the negative rule until the very, very end, just because I think it's easier that way. And we haven't talked about division yet. And so if you don't know how to do the quotient rule, if you do the negative rule first, it can get you in a pickle. Okay, so we can do the power rule. So 3 times 5 is 15. We have x to the 0 and x to the 4th. So that's just going to be x to the 4th. Or you could have marked that out and just been left with x to the 4th. It works either way. And then our y's, we have negative 3 plus negative 2 is negative 5. I can't leave the negative up there, so I have to rewrite it as 15x to the 4th over y to the 5th. Okay? And then let's do one more, just for fun. So negative 4x to the negative 4th, y to the second, z, and then 3, y to the 5th, z to the 3rd. Okay? So on this one, our coefficients are negative 4 and 3, so that's negative 12. All right, I have an x to the 4th and nothing to match it, or negative 4th, so I'm just going to bring it over. My y's, I have 2 and 5 makes 7. My z's, I have 1 and 3 makes 4. I have a negative exponent, okay? The negative coefficient, I don't worry about it because it's not an exponent. So I'm going to rewrite this, negative 12 on top, y to the 7th, z to the 4th, all over x to the 4th. Okay, so when you are simplifying your exponent expressions, then you're taking each piece one at a time, deciding, does it have a negative exponent? If it does, move it. If it has a 0, you can essentially mark it out. And then make sure you check for your other rules. And like I said, if you have problems that have the rules all mixed up, my recommended order would be product, 0, negative. But again, if you know all the rules and remember them from Algebra 1, then you can mix up the order and you should still be able to get to the same answer as me. Okay, now I'm going to go over some of your Math Excel problems real quick. I'll just pick out a few and mark those with you, but I think that we covered most of them in the examples. Okay, here, the first thing that I do want to tell you about your Math Excel work is I had to pick your assignment problems from an Algebra 1 textbook. And so since our class is Algebra 2, I had to put at least one problem from our book on the assignment. And so for all of the assignments in this little mini unit, you'll notice your first question is a pattern. That should be really easy for you to just fill in the next 3 numbers in the pattern. So 10, 20, 30, 40, we'll do 50, 60, 70, so on, okay? So don't let that throw you off. I know that's not what we're talking about today, but you should be able to do that just fine. So number 2, here's an example of the negative rule. So that negative exponent means move, so we're going to move that y. So if x to the 7th is on top, y to the 2nd will go on the bottom, okay? And then number 3 is very similar. We have a negative on the bottom, so you move that to the top and change it to positive. All right, number 4, you have 7t v to the 0 power. We know anything to the 0 power essentially goes away, so we're left with 7t. Okay, number 5 is like number 3 that we did. Number 6, I know that these can be tricky when you have the negative coefficient, but remember the negative coefficient stays where it is. This negative exponent is what moves down, and so that'll be negative 3 over x. And then number 7 is like one we've done already. Number 8, this wants you to write it as an expression with exponents. So your base is going to be 7, and then I will let you do the exponent by yourself. But it wants it in this form, 7 and an exponent. Okay. The rest of them are pretty straightforward, the product rule. Now this one we have parentheses instead of the multiplication dot, but that's okay. You're still going to do it the same way. So you multiply all of your coefficients and then keep your base and add your exponents. Okay. And then your last problem is similar to one that we did. You can do this a couple different ways. I recommend that you combine these and see what you get and then move it. Okay. So I would do 1 over 4 plus negative 6 is negative 2, and then I would rewrite it as a squared. Okay. So that one does require you to do a couple different steps. All right, so that should be plenty to get you through your assignment. If you need help or have questions, please let me know, and I'll be happy to assist you however I can. You can always send me an email, hit Ask My Instructor, or jump back in the Google Meet. Have a great rest of your day.